Have you ever wondered what the universe would look like if you reverse the flow of time? Imagine a massive explosion where light, dust, and planets are being born and moving outward, a place where no outside force can ever step inside. We all know the black hole, the monster that swallows everything. But today, we dive into a mystery that science calls the white hole, a doorway that exists in mathematics but remains far beyond our physical reality. A page from history. Carl Schwarzschild's letter. The year was 1915. Albert Einstein presented his general theory of relativity to the world. But while the world was preoccupied with the battlefield, a German physicist named Carl Schwarzschild, living in the shadow of death, was busy solving Einstein's complex equations. Scientific focus. Schwarzschild showed that if you pack mass into an infinitely small point, the fabric of spacetime rips. Education. Here, we explore the Schwarzschild metric. Einstein's equations had two sides, one that pulls gravity inward and another that, mathematically, pushes everything outward. The magic of mathematics. Plus and minus 15 o'clock to 30 minutes and 0 seconds. Mathematics never lies. Just as the square root of 4 can be both +2 and -2. Einstein's equations had two solutions. One became the black hole, which we have successfully observed. But the second solution was the white hole. Real science. The existence of a white hole relies entirely on time reversibility. If we were to run the laws of physics backward, the end of a black hole becomes the beginning of a white hole. Example, imagine you are watching a film of a glass shattering. If you hit reverse, the shards of glass would spontaneously come together to form a whole glass again. A white hole is the reverse gear of the universe. Event horizon versus anti-horizon. We call the boundary of a black hole the event horizon, a point of no return. However, a white hole has the exact opposite, an anti-horizon. Detailed insight. Matter inside a white hole is ejected outward faster than the speed of light. No matter how hard you try, you can never reach its center. It is a region of space that effectively seals itself off from the rest of the universe. Scientific thought. Is a white hole the source of new energy in our cosmos? Or is it merely a mathematical shadow? Key vocabulary and nuances used. Spacetime. Use the American standard, sometimes written as spacetime. Center. Use the American spelling rather than the British center. General theory of relativity. The standard scientific term in the USA math, shortened from mathematics, as is common in American English. Imagine stepping through a door in New York and, in the very next instant, stepping out onto Mars or into another galaxy entirely. It sounds like science fiction. But in 1935, Albert Einstein and his colleague Nathan-Rosen used mathematics to prove that such bridges could exist in the universe. We call this the Einstein-Rosen bridge. In today's chapter, we will journey through the tunnel that connects to worlds. Scientific depth. The discovery of Einstein and Nathan-Rosen in the 1930s. Einstein was working on a problem that kept him up at night. He wanted to remove the singularity from the fabric of spacetime, a point where the laws of physics completely break down. Scientists focus. Albert Einstein and Nathan-Rosen. Real education. Mathematically, they connected the pit of a black hole to another end. They found that if you stretch the center singularity of a black hole, it becomes like a tube or a tunnel. The other side of this is called a white hole, the birth of a wormhole. Warping spacetime. To understand this, take a piece of paper, mark 2 points on the corners, point A and point B. If you draw a straight line, the path is long. But if you fold the paper in the middle and bring those 2 points on top of each other, you can pass straight through with a needle. This is the principle of a wormhole. Example, you can use the example from the movie Interstellar. Here, where the wormhole is explained. Education. We will explain how the metric tensor warp space so much that distance and time lose their significance. Can we cross this bridge? Now the question arises, can a human pass through this bridge? Mathematics says yes, but physics says probably not. Critical problem. Stability. Einstein-Rosen bridges are so unstable that as soon as even a single ray of light enters them, the bridge immediately collapses. Exotic matter. To keep this tunnel open, we would need a substance with negative energy. This is something that works opposite to gravity, pushing the walls of the tunnel outward to keep it open. Conclusion: the Einstein-Rosen bridge might not just connect to places, but perhaps to different universes. Is the matter falling into a black hole exiting through a white hole in another universe? Are we part of a multiverse? We will find the answers to these questions in the next chapter, where we will discuss thermodynamics and entropy, the laws of the universe that prevent white holes from existing. Does the universe have laws that simply cannot be broken? Just as the police chase down a criminal, the laws of thermodynamics act as a barrier, stopping white holes from becoming a reality. Today, we will explore the historic debate between the great Stephen Hawking and Jacob Bekenstein, a debate that completely reshaped our understanding of black holes and white holes. The second law of thermodynamics states that disorder, or entropy in the universe, is always increasing. If you break a coffee cup, it cannot spontaneously put itself back together. The problem with a white hole is that it appears to run time in reverse, which goes directly against this fundamental law. Do black holes die? The quantum bounce. What happens when a black hole reaches the end of its life? Does it simply vanish? The renowned physicist Carlo Rovelli believes that black holes don't just die, instead, they bounce with an explosion. Just as a ball hits the ground and bounces back up, a dying black hole transforms into a white hole. Loop quantum gravity, the true form of space. To understand this, we must stop looking at space as a flat sheet and start seeing it as a web of fine threads. When the matter inside a black hole becomes so small that it can no longer be compressed, quantum pressure pushes it outward. This phenomenon is what we call a quantum bounce. The illusion of time. The most astonishing part is that time moves incredibly slowly. Inside a black hole, what feels like billions of years to the outside world might only be a few seconds inside the black hole. Because of this, the black holes we see today might have already become white holes. It's just that their light hasn't reached us yet. Closing thought: Carlo Rovelli's theory is creating a massive stir in the scientific community. By peering inside a black hole, could we be looking at our own future? In the next chapter, we will untangle the mysteries of wormholes and time travel that we left unfinished in Chapter 2. Space's secret shortcut, a shortcut through space. Can we travel millions of light years in just a few seconds? In the movie Interstellar, we saw how a wormhole allows travel to another galaxy. But is this just imagination? Or are there truly secret pathways hidden within the fabric of space-time? Today, we will uncover the truth about wormholes, a truth that could prove to be the greatest discovery in the history of science. The theory of Nobel laureate Kip Thorne, the brilliant mind behind the science of Interstellar, was Nobel Prize winner Kip Thorne. He showed the world that creating a wormhole requires more than just a black hole and a white hole. We also need exotic matter. The science. Here, we explain that while gravity pulls things together, exotic matter contains negative energy that pushes things away. This is the force required to keep the throat of the wormhole propped open. Journeying through a wormhole. If you stepped inside a wormhole, what would you see? You would see light bending all around you, and inside a sphere, you would see the distorted images of distant stars. It would be a journey where you witness the very laws of space and time breaking down. Will we be able to build such wormholes ourselves in the future? Or will we have to find them hidden in the cosmos? Danger and instability, but there is a catch. Wormholes are incredibly fragile. The moment any matter or even a message enters them, gravity causes them to collapse instantly. The biggest challenge facing science today is how to keep this bridge stable long enough for humans to pass through. Conclusion: the connection between wormholes and white holes leads us toward the deepest secrets of the universe. Will we ever meet beings from another world through these pathways? In the next chapter, we will discuss a highly controversial topic. Was our Big Bang actually a white hole? The mystery of the beginning. Was the Big Bang a white hole? The secret of the start. Roughly 13.8 billion years ago, an explosion occurred that gave birth to time, space, and matter. We call this the Big Bang. But have you ever noticed how similar the definition of the Big Bang is to that of a white hole? A single point suddenly ejecting a massive amount of energy and matter. That is exactly what a white hole does. Is it possible that what we consider the beginning of our universe was actually the end of a black hole in another universe? Parallel realities. The Big Bang versus the white hole from a scientific perspective. The Big Bang and white holes share incredible similarities. Singularity. Both begin from a point of infinite density. One-way traffic, just as things can only exit a white hole. Our universe has been expanding exclusively outward since the Big Bang. We cannot travel back in time to re-enter that starting point. The Big Bounce theory this brings us to the ideas of Stephen Hawking and Roger Penrose. There is a theory known as conformal cyclic cosmology (CCC). This theory suggests that the universe dies becoming a black hole and is reborn becoming a white hole. Example, just as a dying star becomes a black hole, a dying universe contracts and undergoes a cosmic bounce, emerging on the other side as a new Big Bang, or rather, a white hole. Are we living inside someone else's black hole? This thought is a bit chilling. If the Big Bang was a white hole, it implies that all the matter in our universe originated from a black hole in a parent universe. We might be nothing more than a tiny bubble inside a vast multiverse, born from the opposite end of a massive black hole. If this is true, it means the universe never truly ends. It simply changes its form. But do we have any proof? In the next chapter, we will discuss the strange sounds and mysterious lights from deep space that might be signaling the existence of white holes. We talking about gamma ray bursts. What if I told you that we've likely already seen a white hole, but we simply didn't recognize it? Every now and then, flashes of light appear in deep space that are billions of times brighter than our sun, only to vanish in the blink of an eye. We call these gamma ray bursts GRBS. In 2006, an explosion occurred that left scientists stunned. Was it actually a white hole? GRB 060614, the mysterious event June 14, 2006. NASA's Swift satellite recorded a bizarre explosion. Typically, gamma ray bursts are either very short from colliding neutron stars or very long from a supernova. But this explosion lasted 100 seconds, and there was no supernova behind it. Scientists had no answer, except for one, that it was the birth of a white hole. Education. Here, we explore how scientists like Alon Redder and Shlomo Heller analyzed this data and concluded that the event matched the theoretical signatures of a white hole. Through the lens of space telescopes, we are observing the cosmos through the eyes of Hubble, and now the James Webb Space Telescope. Why is finding a white hole so difficult? Because they exist for only a fleeting moment. They are like the invisible ghosts of the universe. In this chapter, we will see how radio telescopes and X-ray imaging are scouring the corners of space, where white holes might be hiding. Are white holes part of dark matter? Another shocking theory suggests that white holes don't disappear entirely. Once their explosion settles, they transform into microscopic remnants. Scientists believe that these tiny white holes could collectively form dark matter, the mysterious substance that holds the entire universe together. Closing. If gamma ray bursts are indeed white holes, it means we finally have evidence for this theory. But are these white holes dangerous to us, or will they become our gateway to the stars in the future? In the next chapter, we will ask, is it possible to actually go near a white hole? A hypothetical journey. If we had a spacecraft today capable of traveling at the speed of light, and we headed toward a white hole, what would happen? Could we enter it, or would it hurl us to the opposite end of the universe? A journey into a black hole is a death sentence, but a journey into a white hole, that is a direct war against the laws of physics. Let's begin the most dangerous imaginary voyage in human history. The repelling force as our ship approaches the white hole. We would experience something truly bizarre. While a black hole pulls you in, a white hole pushes you away. Its anti-gravity would be so powerful that reaching it would require infinite energy. Education. Here, we introduced the Cauchy horizon. This is a mathematical boundary that is impossible for any external matter to cross. A white hole effectively shields itself from the outside world. Time dilation, the behavior of time near a white hole, would be mind-blowing. As we attempt to get closer, time for us would slow down so significantly that centuries would pass in the outside world. Example, imagine watching a white hole. The matter being ejected would appear to move in slow motion, yet in reality, it is moving faster than the speed of light. This is a paradox that the human mind cannot easily grasp. The radiation threat the firewall even if we somehow manage to get close. The extreme temperatures and radiation would vaporize us in an instant. The gamma rays shooting out of a white hole are so intense they could burn through a sheet of iron. Like it was paper, without an exotic shield. Going there is nothing short of suicide. Closing thought, so, is traveling to a white hole just a dream for today? Perhaps the answer is yes, but for advanced future civilizations, it could be an interstellar highway. But what if we found ourselves emerging out of a white hole from the inside? In the next chapter, we ask a profound question. Are white holes and black holes just the sides of the same coin? Greatest puzzle, the universe's greatest puzzle, isn't where white holes are hidden, but whether they are actually just black holes in disguise. What we see going in is a black hole. What we see coming out is a white hole. Is it possible that the same door acts as an inlet on one side and an outlet on the other? Today, we will unravel the mystery of the unified theory that could change the direction of science forever. The mathematical mirror and the language of mathematics. Black holes and white holes are perfect reflections of each other. Education. If you take the mathematics of a black hole and reverse the arrow of time, it becomes a white hole. Scientists believe the singularity is the point where these two meet. Think of it like a cosmic funnel. Wide at the top, black hole, and wide at the bottom, white hole. Connected by an incredibly narrow passage in the middle. The Journey of Information, Stephen Hawking. She asked a profound question. If a book falls into a black hole, is the information within it lost forever? The new theory, the principle of unitarity, states that information can never be destroyed. Therefore, whatever a black hole swallows must eventually return from somewhere. A white hole is that exhaust pipe, recycling the information of the universe and sending it back out. The universal recycling plant. Think of our universe as a massive recycling plant. Stars die and become black holes. They compress matter, and then, through white holes, that matter is released back into the cosmos to build new stars and planets. From this perspective, white holes are not agents of destruction, but deities of creation. Closing thought, do black holes and white holes together create an eternal cycle? If so, the universe may never truly end. But what is the ultimate truth of this story? In our final chapter, we discuss the final word. Are white holes the key to our existence? Everything we know today is the result of someone's curiosity. There was a time when black holes were nothing more than a puzzle on a sheet of paper. But today, we have actual images of them. Perhaps tomorrow, the discovery of white holes will reveal the true path to time travel or the multiverse. Friends, as vast as the depths of the universe may be, the human thirst for knowledge is equally limitless. I am a new creator, and this is the very first video on this channel. I have poured my heart and soul into producing this video to ensure you receive the most accurate and high-quality scientific information. My goal isn't just to make videos, it's to dive deep alongside you into the worlds of science, history's mysteries, unsolved cases, and the greatest secrets of the business world. Starting a new journey is always a challenge, and it's simply not possible without your support. If you enjoyed this effort even a little, please like this video and subscribe to the channel to encourage me. Your small act of support gives me the strength to create even more mind-bending documentaries in the future. Let me know in the comments, what do you think of this white hole theory? Do you believe we will ever be able to peer inside one?